Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. DSPy, programming, not prompting language models. And the library that we are going to dive into right now, it actually aligns with the motto of this particular series of videos, that you automate large language models. Automating is very close to what you do in programming. In case of DSPy, they have made it very intuitive and also, in fact, very simple. You'll see that in this discussion, which will be pretty short, we will discuss about what is DSPy first of all, and then we will try to understand the parts of DSPy here, and we will then move to talk about the things that you can do with DSPy, and finally a basic example. Most probably 10 to 15 minutes of video. DSPy started with something called as DSP. It's the initial library name. DSP means demonstrate, search, and predict. Now they have modified the name to call it as DSPy. So demonstrate, search, predict, and I think with Python. That's something that I think of, but it's not what I found in their website or in the GitHub repo that they have shared. If you go to their website, which the link will be, I'll be sharing it, and also the GitHub repo link also will be shared. If you click on the GitHub link at the top, you will be taken to this particular repository inside the GitHub. Now, so the DSPy library has been developed by Stanford NLP group, and it is done by not just 1 or 2 person. It is done by a lot of people. So you can see the various people who are involved here. So Mr. Katab is the person who is leading the team, and also there are lots of players, lots of programmers who are supporting him. The details are also provided at the bottom. Here in the website, you can see DSPy has a process. It says that it is going to do systematic optimization, it is having a modular approach, and it has got cross LM compatibility. Now these might sound very abstract, and their documentation is, very strong. The documentations provide a lot of information, give a very good tutorials, and also a very substantiated deep dive on the APIs. Everything has been provided in the documentation. You can take a look at that, and what we are going to do in this discussion is that we are going to first of all think about what DSPy does. DSPy, the Python library, provides a general purpose modules that can replace string-based prompting. So what I mean by string-based prompting, so if you go to any of the large language model application, what you're going to do is you are going to tell to the large language model that you need something, and you are going to do that using a series of prompts. Sometimes the prompt will work, sometimes the prompt may not work, so you will have to modify the prompt. So this is the key aspect that I'm talking about. You will modify the prompt, and for some time the prompt will work, and after some time the prompt starts failing. That is one thing. Second thing is, the same prompt that you are using in OpenAI, for an example, OpenAI GPT 3.5 Turbo may not actually work with GPT-4, or it may not work with any of the open source LLMs. So the prompt configuration that you need to use, I shouldn't say configuration. So there is something different here. It's called as a signature, because prompt is given in English, right? And it doesn't have a formal syntax. Yes, it has grammar. It doesn't have programming syntax. So because of this kind of differentiation, we call the prompt, the way we prompt something, as signatures. And you'll be surprised that we will have a look at all these things and how they are automating the signature in a couple of minutes, but I am going ahead of myself. DSPy also provides optimizers which can optimize these modules with the help of the following. So the optimizers in DSPy can actually modify the prompts that you provide. You heard me right. It can automatically modify the prompts, and also it can do fine tuning of your large language models. Both of these can be done. But right now, if I tell you how that is going to be done, how it happens, it's not going to stick with you. Believe me, I have tried watching other videos. I tried reading through the documentations for last 2 days. Nope, it's not straightforward. You have to understand at least you should understand how the basic Python frameworks work, how PyTorch framework works. And let's not get into the complication. So let us see what we can actually do right now in this video, and we keep it simple. So what are the various modules in DSPy? We have modules like language modules, that is language models. That is a basic thing. You will need a language model. You will need signatures. Modules is different from the modules that you're talking about. So they have something called as modules inside DSPy also. And then we have data. Yeah, they have a very different way of representing data. And the data, the way they represent it is something that I will cover separately. So stay tuned for that. They have metrics, they have optimizers and assertions. These are the building blocks. Sorry about that. So what are the use cases? When it comes to DSPy use cases, it can do all kinds of NLP tasks that you are aware of, like question answering, multi-choice question, summarizing, classification, tell whatever it is. And all these things, it will actually consider it as a text generation task. It will use that only. So you give a prompt, you tell the model to classify this or classify this statement, get the sentiment or answer this question. But the way you do that is what will be surprising. So let me move to the next step. So can we see a basic example? Yep, we are going to dive into that. In order to look into the basic example, there are a couple of steps that you need to follow. First, you have to install DSPy-AI. That is the installation process that you need to follow. If you go back to the website, if you go to installation, you'll see that you can actually install it. And also you can install various supporting vector stores when you're doing this particular DSPy-AI installation. So I prefer ChromaDB. I think they have support for various other vector data stores also, like VV8, but I think they have not shared it here. And also it's actually super easy to connect vector stores. I will discuss about that in a separate discussion in near future. That's about installation. And now let us go back to the minimal working example. Also, one more point I missed about the installation. When you are going to install, do create a virtual environment and install it there. If you look at my particular VS Code setup, if you go here, you will see that I have a lot of virtual environments here. Now in VS Code, it is super easy to get access to various virtual environments. It's initially it was confusing, but now if you do a Shift P and if you Control Shift P, sorry about that, and if you say Python select interpreter, if you scroll down and select at workspace level, and there you can actually enter interpreter path, then you can find the interpreter. So when you do this, you can actually find the exact interpreter location, and you can work with that without any kind of a problem with that particular interpreter. That gives you a lot of control, because you wouldn't want your existing Python installation, the mother installation, I will call that, to be corrupted by any of the libraries that you don't want. Sometimes the libraries will upgrade the existing libraries, and that upgrade might actually break other programs in your system. So keep a virtual environment. It's very, very important. It initially is tough to understand and follow, but as you force yourself to use virtual environments, it becomes super easy. Getting back on track for the basic example. So we have seen like what are the basic DSPy modules, what DSPy does. Now we are going to see a basic how-to of DSPy. First, we are going to work with OpenAI GPT 3.5 Turbo, and I'm going to load my API keys from this particular .env file, and this env file is going to contain my OpenAI API key variable. In that, it will have the OpenAI API key, and I'm going to use load.env. Then I'm going to import OpenAI, I'm going to import OS, and then I'm going to import these modules. So signature I will not be using. I'll be using OpenAI module. I'll be using predict module. I'll be using predict object. I'll be using OpenAI object, and I'll also be using settings objects from DSPy. So that is how I am going to import, and I am also importing warnings so that I can filter it. I don't want any of the warnings to interrupt. So you can see that I am assigning the OpenAI.API key with the environmental variable here. That is how I am going to get the OpenAI API key. There are other ways to do it. I'll show that in a couple of minutes. Next, I am going to start the creating the large language model. In order to create the large language model, you have to call the OpenAI object inside DSPy, and for that you need to provide the model, you need to provide the API key. So you can provide the API key here also. You can provide the API provider. That's something that you can share, and you can also provide the model type. Most of the time, you don't need to provide any of these things if you follow this process, the process that I already told. So you have to just give the model here. So once you give the model here, I have given GPT 3.5 Turbo, and after that you need to call settings.configure, and you need to send this Turbo into the configure function. Here, one important point that I observed in DSPy is that you need to provide the parameters or the arguments in the named format. If you don't provide the name, then there are surprising errors that come up. So what I mean by this is that instead of settings, let me actually show you. Sometimes it's better to show than actually explain. So if you give the same command settings.configure without LM equal to and just give Turbo, there could be situations where it will error out. So better avoid this. Always give the proper name of the parameter or the argument, and then give the value to it. So in that way, you can be assured that there will not be any errors. If you are not aware, initially this will be little troubling, and it will actually pull you out of the flow when you are learning. But as you practice these things, it will become second nature. Continuing further. After you configure it, you can just directly prompt the OpenAI like this. Hi there, I am using DSPy. And the moment you prompt it through Turbo, you will see that it is responding back. But what you will see is it is actually responding back as a list. You see there is a square bracket here. So it's a Python list. What is happening? You should never directly prompt the large language model like this. You should never do this. Even DSPy documentation talks about this, that you should not directly prompt it. The best way to prompt it is to use the modules. There are lots of other modules that I'll be discussing separately in this series of videos, but we are going to use a module called as predict. So the predict module or the predict class is going to take a signature. Signature is a string, and the signature can be a object in itself. So we will see that in the future. But here we are just giving a string, and the string contains question followed by this symbol that is an arrow and an answer. These two, question and answer, are the variables. And what happens internally will be the surprising part. So once I give this, once I create this predict object, because this is a predict class, I am going to give the string here, and that is going to create an object called pred_mod. It is going to create an object and assign it to pred_mod variable. After that, I am going to use the pred_mod, and I am going to send the question. You see, this question and this question equal to has to match. Basically, once I create this predict object, I can do the inference by sending the question or sending the prompts through the question variable. If I don't send the prompt through question, then it will actually error out. Keep this in mind. I need to send it through question. I need to say question equal to where is lunar landing. If I don't do that, so if I remove this and if I execute this, there is an opportunity of this type error. Why this type error is happening is that the predict.call method takes one positional argument, but two were given. So we did not give two, but why it is saying two were given? This is because we have basically not given this question equal to process here, syntax here. The error is not very informative, but once you understand, go deeper into how the predict class has been implemented, then you will understand why this issue is coming out. But right now, I'm not going to discuss that. So question equal to where is the lunar landing happened the first time. So if I do this, then what will happen is the model will be called and the appropriate answer will be given. So the output of if you look at the actual output of the model through the predict object, it will be a prediction object. So this is a predict object, this is a predict object that is getting created, and a predict object returns a prediction object. And what are these objects? So why are these objects so important? You will see that these ways of defining the types of what is going in and what is coming out of the large language models, and how these types contain the data, because the prediction contains the answer and the question also. So both of these things it contains, and when you do the model out.answer, you will get both the question that you sent and the answer also. So where is the lunar landing happened the first time? The first time lunar landing happened on the moon. GPT 3.5 turbo is sending out gibberish, but it's fine. But it gave us an answer. I mean, lunar landing will happen on moon. We know that, but still. And what comes next is more important. You can actually look at the history of calls that we have made to the language model. The history is kept inside this particular object, that is a language model object, and you can access it like this, which is not very useful. The better way to access it is using the turbo.inspect history n equal to 3. So when you access it like this, then you will see that what kind of prompt was sent and what kind of question and answer was received. So you will see here that given the fields question, produce the fields answer. Just for a moment think, I did not give this kind of a prompt, and following this also you will see there is an additional step. So here it is saying follow the question format. It is saying question, here it should be question, and answer, here it should be answer. But none of these things I gave. I had just told that predict question answer. So what happens is inside the predict class, the predict object is created, and the predict object, when it is created, all these prompts are automatically written for you. So it's done automatically. And when we talk about optimizing the prompts, these prompts are what gets optimized. Yeah, this is something that is called as programming prompts. I mean, you are going to modify the prompts and you are not going to touch it, or you are not going to do it manually. That is, I mean, one of the most important things that I want you guys to take home right now from this video. We will actually go step by step. You might be wondering that how is this even possible? How can the code do it? How Python can do it? No, Python is not going to do it. Python is actually going to be the interface through which we are going to call the language models, and the language models along with various other Python modules inside DSPy are going to do that, make it happen, along with support of language models. So keep that in mind. Language models are going to stay, but they are going to stay in the coding method only. We have to code it, we have to program them, no other option. But we are going to program it in a much more simpler and easier syntax. So that's the thing. You can see that the question is what we asked, and this is the answer that has been returned by the language model. So I believe that you have got a good overview on what is DSPy and why DSPy, how the DSPy works, what are the various modules inside it. We have seen the overview right now. I will be diving into what are we going to look at next. So what we will do next is we will actually look at how to configure the language models, like work with OpenAI. So you already saw this. We will work with HF models, that is Hugging Face open source models, and also Ollama models in the next video. And also I'll be showing some tasks being performed with these models. That's going to be pretty interesting. That's something that you guys will be, looking forward. I'm pretty sure about that. So stay tuned for that. Also, why DSPy? It streamlines the process of prompt engineering. So you saw that. It knows, we from the beginning know what is the input and the objective. What is objective? Just think about it. If you are going to do a question answering, you want the right answer. If you are going to do a classification, you want the right classification or the sentiment. If you are going to create a JSON object, you want the right kind of JSON object with whatever data you are going to push into it. How are you going to make this happen with multiple ways of prompting it and breaking your head? No, that's not how it you don't need to break your head. All you need to know is what you exactly want and how to train the language model and how to optimize them using DSPy. So you can create modules of language models, you can train the modules, you can evaluate the modules, and you can even fine-tune smaller models like T5 and Bert. This is pretty advanced, I'm telling you. I mean, even evaluate for that matter is a little bit advanced, but once you understand the basics, this is going to be pretty fun. So stay tuned for the next video. We will dive into language model creations inside DSPy using HF models and Ollama models. And also we'll be performing some basic tasks. With that said, I would like to leave this video with 4 words: keep prompting, keep prompting. See you guys. Have a great time.